Hello and a very warm welcome to another discussion on our series on neuroscience and neural networks. Last time around, we looked into action potential. We identified a resting state, a depolarization state, a repolarization state, a refractory period, and then the resting state again. Also, we identified that the action potential, the nerve impulse, the information, electrical activity, this is very specific and very localized to each part of the axon. So no two processes could take place at one location on the axon at one time instance. While there's action potential in one place, there's another activity that's going on adjacent to it. Then the action potential moves on to the adjacent part of the axon. Then the action potential would move on to the adjacent part of the axon again. And then so on and so forth, the action potential will move across the axon all the way to the axon terminals. Once it reaches the axon terminals, it's meant to move into another neuron, the dendrites of the other neuron. Okay, but how does that happen? This is the scope of this video. There are, in fact, two ways for the information to be moving from one axon to the dendrite of the other neuron. One of the ways is electrical synapse, and the other way is the chemical synapse. The electrical synapse is very simple to understand because it follows from the same phenomena of action potential that we have studied earlier. The electrical synapse requires that the two neurons are in contact with each other and there's a pore set up between them such that ions could pass through those pores. Okay, so in fact it is more or less an extension of the first neuron. You would see something like this, that if I were to zoom this in, you would see something like a dendrite of the other neuron connecting with the axon of this neuron. And if I were to further zoom in on this part, we would in fact be seeing this pore right here set up between this connection. So this is basically one neuron and this is the other neuron. They're both in contact with each other via this pore. Okay, so there is some sort of a channel between the two. Why is this channel important? This channel is important because of ion transfer. Okay, remember that the reason you have action potential is because of the relative potential of the neuron. Remember how sodium ions had to move in to depolarize the neuron. Remember from the last video, the sodium ions would move in and then the neuron would depolarize and its potential would rise. So the same happens here when the action potential reaches this point, this junction, this pore. The action potential simply moves on to the other neuron. So in fact it's as if the same neuron is extended into another. So there's a contact between the two of them. That is the electrical synapse. The chemical synapse, however, is slightly different in that there is a gap between the two neurons. So we consider this to be the first neuron, the presynaptic neuron, the neuron that is the initiating neuron, which is carrying the nerve impulse, the action potential, the information, the message. And then this is the receptor neuron or the postsynaptic neuron, which is going to be receiving that impulse and then moving along. So the nerve impulse comes to a point where there is a need to transfer that nerve impulse to the other neuron. And how does that happen? Again, the sodium ions play a fundamental role. They trigger these molecules, also called as vesicles, to release these neurotransmitter molecules. Refer to them as vesicles. So these vesicles containing neurotransmitter molecules, the sodium ions trigger them to bind to the membrane, and that allows them to break open and let free these neurotransmitter molecules into the synaptic cleft. So we could call this a synapse, but strictly speaking, this entire place would be synaptic cleft. Okay, so these neurotransmitter molecules move into the synaptic cleft. Some of them get wasted and they move around, but these would ideally be intended to land at the receptor of the second neuron. Remember, these neurotransmitter molecules are very specific in their shape, and the receptors are also very specific. These binding sites are very specific, so it's a lock and key mechanism where specific neurotransmitter molecules would land at specific receptors, okay, for one kind of neuronal transmission. There are many different types of neurotransmitters, so another type of neurotransmitter cannot land at these receptors. That is the point. So once these neurotransmitters land, these protein structures land at these receptors, this triggers another signal in this neuron, which leads to a generation of an action potential in the second neuron, and then that action potential moves along the second neuron. In that way, the action potential coming in from the first neuron is in fact, after a scheme of things, thanks to neurotransmitter molecules here, you have the action potential moving across the second neuron as well. Another implementation of this is here, okay, where this is the action potential that is, and then the sodium ions are triggering these vesicles to bind to the membrane, which breaks open the neurotransmitter molecules, which in turn bind at specific receptor sites, which yields or triggers another signal in the secondary neuron to generate an action potential, which is then carried on. These neurotransmitter molecules, some of them are metabolized, some of them get acted upon by enzymes, but most of them, there's a recycling mechanism that there are certain gated channels here. Those gated channels allow these neurotransmitter molecules to get back into the original neuron for a reuptake mechanism. This is called a reuptake mechanism. This allows the recycling of these neurotransmitter molecules, so they don't get wasted for another action potential coming in. Okay, so for just a comparison, which is also very intuitive, the electrical synapse would obviously be quicker than the chemical synapse, because this process would obviously take time as compared to the electrical synapse, which is a connection, essentially a connection between the two neurons. However, one important thing is there is a lot of modification that could take place, and we will talk about this in the next video. However, the specificity of these neurotransmitters is of great importance, because just about any other neurotransmitter cannot get logged in with these receptors. There are only specific neurotransmitters that get logged in with these specific receptors. With that, we will conclude this session. More on neurotransmitters in the next video. Thank you so much.